Last problem for this section. A cone has radius r and height r. Find a formula for its volume. Okay, so this is for a particular cone where the radius of the cone and the height of the cone are the same. Like that. So what we need to do first is come up with a function that we can rotate around something to get this. And I think what we can do here is just take the curve y equals x. And you could rotate that around the x-axis and get the cone we want here, where the radius and the height are the same. You could also rotate it around the y-axis, the same curve. Rotate that, well, it's not a curve, it's a straight line, but rotate it around the y-axis and get the same thing. So in both of these, we're using the function y equals x, and we can rotate it around to either one. Either would work. I'm going to use the first one. All right, so if I draw in a band here, it's going to look like this. I'm going to draw it in really thin. So we've got a band there, and the radius of the thing on this one is going to be y. But of course, y equals x, so we can use y or x there. All right, y equals x. If we take the derivative of this, we just get 1. And then if you start squaring that, you just get 1 out of it. So my ds is going to be 1 plus 1 dy. So ds is square root of 2 dy. All right, so that's our ds, and so our surface area is 2 pi integral of radius. Now remember, our radius is y, but since y and x are equal to each other, put in x times, this should be dx up here, square root of 1, or square root of 2 dx. And going from one end, or from one place to the other, we're going from 0 to r. Because we didn't have a specified radius on this, and we just said the radius is r. So let's integrate this and see what we get. So I get 2 pi, square root of 2. And when I integrate the x, I get 1/2 x squared from 0 to r. So let's see, the 2 and the half cancel. So you're left with pi times root 2 times r squared. Now, it would be nice to be able to check this, but I don't know the formula for the surface area of a cone. Up here, this said volume is supposed to say surface area. So let's Google it. Let's see. Surface area of cone. Okay, it gives us a formula for a right circular cone, which is what we want. Now, the formula they're giving us has one value for pi. It has separate variables, one for r and one for h. But what we're doing here is we're using, in our special case, we've got the height and radius equal to each other. So what I'm going to do is I'm going to I'm going to plug in r for both r and h. If I do that, let's see, I get surface area according to them is pi times r plus square root of r squared plus r squared. Okay, so inside of here we've got 2r squared Now I can factor that into square root of 2 times square root of r squared, so we get that. I can factor out an r, so I get pi times r squared 1 plus root 2. And that's not what we got above. Okay, like 2 seconds after I stopped the video, I realized what the difference here is. Um, what we calculated up here is the surface area just of the side of the cone. This over here that Google gives us is the surface area of the side and the base of the cone. If you look at it, the square root 2, this bit here gives you, this bit times pi r squared gives you what we had. This times pi r squared just adds on the area of the circle on the end of the cone. So my question, I guess I could have been a little more clear about it. I just wanted the surface area of the side of the cone. All right, so anyway, that'll do it.